Let's take a few minutes to look at thermal irradiance as a feature and why we do it, getting out of the realm of the detailed analysis and looking at the system diagrams and the thermal irradiance plots and the thermal irradiance numbers, and just look at why we do it from a higher level. So to talk about thermal irradiance and why we do it, let's first talk about what thermal irradiance is. Thermal irradiance can be understood by just thinking about this. When we're around hot objects, we feel their heat. A radiant heater that is glowing red or yellow or white can be felt from some distance. And it's not because the air from it is circulating to us necessarily. It's simply the radiation that beams through space to us from it. And if those objects are hot enough, we see light that is produced by that heat, as well as feeling that thermal effect. So we may say something is red hot or white hot or straw-colored hot, which is used in steel and iron processing because it's a useful temperature range for some operations. The thermal irradiance source that we are probably collectively most familiar with is the sun. A great big, very hot ball of gas that glows, produces visible light, as well as producing infrared radiation that we might measure. A little closer to home, literally, is a heater core that is heating up something to incandescent white or red. It says red hot in the title, but that looks pretty yellow or white to me. And there's a measurement device that's showing a temperature. Here we have an incandescent body of steel, liquid, white hot, in a crucible being poured. Here a blacksmith with very hot glowing metal that is being worked. And so all of those are examples that we might be able to both see some light, visible light coming from it, and feel the radiation from it. The heat that we feel but can't see is still electromagnetic radiation, just like the light that we see. We can measure and image that radiation. And there are sensors that allow us to make cameras to record it, either as still images or as moving images or video. And we might develop instruments or cameras that measure absolute temperature, or we might measure temperature differences across an image. Either might be the goal of an instrument. And we need to be able to design the optics for these systems just as we design the optics for visual light systems. And we need to be able to predict the performance and look for possible problems in design and correct them. So let's look at a few sort of vertical market examples of where you might do this kind of thermal imaging or thermography or such things. We might use it in industrial monitoring or control, looking at energy usage, efficiency, or safety, transportation safety and maintenance, health and medical applications, environmental and agricultural, and things like surveillance, security, and intelligence, because we can see with infrared things that we can't readily see with our eye or with visible light cameras. So going to the industrial process monitoring first, this is an example of a process to build rollers that are used for roll forging. This is basically like chromium steel that is being forged itself to make one of these rollers. And this was actually done using a visible light camera with an extreme red filter around 690 nanometers. And so it certainly produces heat, but it also produces a little bit of light that we could see with our eye or with a visible light camera. Here is an example of drones carrying an infrared camera and looking at the light, the infrared radiation that is coming from residential areas, so that we see where light is, or where heat is being lost in those houses. This could be done for commercial setting as well. Here is a closer up example of looking at thermal infiltration by door seals. So basically a bad seal on a door allowing cold air to infiltrate a warmed interior of a house. This is an example of of electrical circuits in a home being examined using thermography. and seeing that one of these devices is a little bit hotter than the others, and that could be indicative of a problem. And we might want to know this both to avoid failure of the device later at an inconvenient time, or of the device actually operating at an unsafe temperature, possibly causing a fire. Here we have a trolley with a hot engine, and we see an adjacent vehicle with these orange glowing tires. We can use thermography to look at whether the engine is hotter than it should be, whether the tires are hotter, and if we look closely, whether the tires have, for instance, a hot spot that indicates that they may be about to fail. And this could also be used for other parts of motor vehicles, like the braking systems, to know if they are likely to fail because of overheating, or having overheating indicate that they are prone to failure. Here we have a health application. This is basically looking at lymph node metastasis in the oral cavity by looking at thermal signatures. And there are basically 4 different kinds of thermal signatures considered in this paper, and the whole paper is available open access if you would like to know more. Here we have some bare ground and some ground that has ground cover being imaged, and we see that the bare ground is much warmer than the area where the ground cover is. And this might be applied to mitigating heat island effects in cities, or mitigating heat in other places where it matters. I mean, for instance, you might have livestock that needs a particular access to cooler temperatures, and ground cover might be able to help you do that. And finally, in the lower left, this is a hop field that was mapped using visible and then infrared light. And this thermal radiation excess here, indicated in red, shows that part of the field is in a different condition than the other part of the field. And in this particular case, it was found that the crop in the red areas was not healthy and was not going to be a viable crop. It wasn't going to be a saleable crop. So a decision might be made not to waste the energy and effort in harvesting that. So those are a few of many possible applications, and some colorful illustration of those applications. So that's an introduction to thermal irradiance, why we might measure it, where those applications are, and how it may be useful. Thank you very much for your attention, and I look forward to working with you.